Okay, so in this video, we're going to go over and review the characteristics of graphs. So all of those things that we've talked about in class, all those different parts, domain and range and maximum, minimum, all those parts are considered characteristics or key features of graphs. So that's what we're going to cover in this video. So let's first look at the function that we have here. A couple things that I would like to point out about this graph is things that I want you to recognize, such as the fact that this is a fourth degree polynomial. So it has those 4 zeros with those green dots. So it's a fourth degree polynomial. So it's an x to the fourth. Okay. And that is important in understanding the sign of the leading coefficient, which again, remember that for the sign of the leading coefficient, you know that by the end behavior, but remember all even degree polynomials in behavior either goes both up or both down. And then for odd degree, they go in opposite directions. So the leading coefficient tells me the right-hand side. So positive leading coefficient, right-hand side goes up. Negative leading coefficient, right-hand side goes down. So let's look at the first question, domain. So when we look at the domain, we read the graph from left to right. So these are, in fact, arrows. So my domain would definitely be all real numbers. This is going to continue from left to right forever and ever and ever. Range, however, if you were to go down here past -7, there's literally nothing below the graph. The graph does not, below that section, the graph does not go past -7. So -7 is my lowest point, and it is included with brackets. If it was an open dot, you would very clearly see an open dot. Since there's no clear open dot, that means it's a nice continuous graph. And so -7 is definitely included, and then it continues on to positive infinity. X-intercepts, so where the graph crosses the x-axis, and I've already dotted those in green, also known as zeros. So remember, for x-intercepts, we want to list an ordered pair. For zeros, we can just list the value of the zeros. So we have 4 zeros in those 3 spots. So the x-intercepts would be then -2, 0, -1, 0. It goes to the origin at 0, 0, and also goes through 2, 0. Okay. Y-intercept, where it crosses the y-axis, it only touches the y-axis at one location, which is the origin. Absolute max. So does this graph have an absolute max? So a point that is higher than all the other points? Clearly not. We have 2 arrows pointing up. So that means it's going to continue forever in the positive y direction. So that means my max is D and E or none. So the sign of the leading coefficient, because this is an even polynomial, both my ends go up, which tells me that I have a positive leading coefficient. So is it a function? Well, that's the vertical line test. So we would do the vertical line test, right? So we move this across, across, across. As long as it doesn't touch the graph in more than one point, then it is a function. So we can definitely say that this is a function. So yes. Zeros, we already have those with the x-intercepts. It's just a matter of listing them. So we could use set notation, or you could do a list. Either is acceptable. In behavior, so as x approaches positive infinity and as x approaches negative infinity, these two things will always be true. The graph will always go to the right and to the left. In the scope of this class, it will. So as x goes to the right, that's positive infinity, we have to the right. What direction would I have to go to touch my function? Well, I'd have to go up. So that means that y approaches positive infinity. As x goes to negative infinity, which is to the left, what direction would I have to go to touch the graph? And that would be up. So that would be y approaches positive infinity. Okay, so domain and range. So this is not a continuous function. So when we talk about continuous versus discrete, so discrete has just like a littering of individual points. And then they say, well, it's continuous if those points are connected. Okay. But when we really get in depth and we start defining continuity, continuity basically boils down to one thing. Can you trace this graph without having to pick up your pencil? So the question becomes, can I trace this graph without having to pick up my pencil? And the answer is no. Okay, so I have this line. I trace, trace, trace. In order to get to the second line, I would have to pick up my pencil or I would connect these two lines, and they don't connect. So I just wanted to clarify continuity for you. Okay, so let's look at domain. So how far left does the graph go? That would be -6 with a parenthesis because it's an open dot. So there is a gap, but it's not a gap in the x's. Those two, the -2, it overlaps each other and continues on until we get here. And then we have an open dot at 1. So it's not included. Union, I pick right back up on the other side of 1. So 1, 2, +4 included because it's a closed dot. The range, so the graph goes down to -2, and then it goes all the way up to +4. So in the range, this is not affected because there's a closed dot on that y value. X-intercepts, so we have -2, 0, 0, 0, and 2, 0. Y-intercepts, so where it crosses the y-axis, 0, 0. So areas of increase, okay? So areas of increase are where when we read the graph from left to right, the graph is going up. So from here to here, I'm going down. From here to here, I'm going down. And from here to here, I'm going up. Here to here, I'm going up. So remember, we use interval notation with respect to x, and we never use included bars because the turning point can't be increasing and decreasing at the same time. It's a turning point. So we're going to use parentheses. So my areas of increase are listed in red. So that would be -2 to +1 and 2 to +4. Areas of decrease are in green. So that'd be -6 to -2 and 1 to 2. Absolute maximum, the highest point of the graph, has a y value of 4. You can list the order pair or just the y. You can go ahead and just list the y. If it's multiple points, you wouldn't have to list multiple because just the 4 itself is the maximum output. The absolute minimum is -2. I have 2 turning points. So I have I have 3 turning points. 1, 1, 2, 0. And then this one might be a little confusing. I would accept either one of those as turning points. I'm going to list where it actually starts going positive. So I'm going to do -2, -2. If there's any overlapping, those just happen to be both included, and there's that gap. I would accept either answer. Is this graph a function? So does it pass the vertical line test? And it does not because of what I've already have circled here with those 2 closed dots. So this is a no. So is the graph 1 to 1? So would it pass the horizontal line test? The answer to that is also no, because you have several overlapping points right there in that section. Okay, so we have domain would be -6 included to -2 not included, union -2 to infinity. So this is an arrow here. So my range would be -infinity up to -2. Union picks back up at -1 not included up to y = 2 included. Turning points, at no point does this change direction. It's decreasing across the entire graph. It is decreasing across the entire graph. So don't put -infinity to +infinity for areas of decrease because this doesn't go to -infinity. So it'd be -6 to +infinity. Absolute max is 2. there is not an absolute min because we have this arrow going down. Is this a function? So does it pass the vertical line test? Yes, it does. Does it pass the horizontal line test? Yes, it does. And what about the value of f of 2? So we have 2 points at -2. However, neither one of those are filled in, so the graph is not defined at -2.